Hey, it's Mr. Lum again, and we're going to continue on with some Chapter 5 stuff for Unit 5, and today we're going to be talking about the electrochemical cell. So first we have to do is a little bit of vocabulary. So the first vocab word is electrode. An electrode is a conductor where a half reaction occurs. So here there are two electrodes in here. Here is one electrode. Okay, I'm just going to color it red. So here's one of the electrodes, and here is the other electrode. I'm going to color it blue. Now these are the sites, or the places, where a half reaction is happening. So how do you tell which half reaction is happening? So I have a piece of our table right here, and what we see is that we have Zn solid right here, and we also have Zn in solution, or in other words Zn2 plus. Okay, Zn2 plus. We also have Pb solid right here. And we also have Pb in solution with PbNO3 too. So you have these four things that could possibly react. So which one's going to do it? Well, in a spontaneous reaction, we know that these two are going to be reacting. We learned that from one of the previous videos. The strongest oxidizing agent is going to be reacting with the strongest reducing agent. So the strongest oxidizing agent is Pb2 plus. And the strongest reducing agent is Zn solid. And they're going to be making Zn2 plus and Pb solid. So there's two half reactions here. So this is the full redox reaction right here. Now there's two half reactions. The first half reaction is this one right here, where you're having Pb2 plus plus 2 electrons makes Pb solid, and we see that right here. So Pb right here is gaining 2 electrons to make this one, and Zn solid is losing 2 electrons to make Zn2 plus. So what we can say is that here's Zn right here. It's losing 2 electrons. So the 2 electrons are going through this wire. Electrons are going through this wire, okay, and transferring down and going into Pb. And we can see that right here. 2 electrons are clearly leaving Zn, and Pb gains 2 electrons over on this side. So what happens is Zn right here is losing 2 electrons, and this Zn is turning into Zn2 plus. So this solid piece of Zn right here, zinc, is turning into is coming out into the solution as Zn2 plus. So since this one is losing electrons, we know that losing electrons is oxidation, and that is the site of the anode. Losing electrons is oxidation, and that's the site of the anode. This one is gaining electrons. Gaining electrons, that is the site of reduction, and therefore this is the cathode. Okay, so two weird things to remember, Leoa and Gurk. Okay, so what is happening is these ions that are in solution, this Pb ions right here, so you have in solution you have Pb2+, right here, and it's going to be turning into Pb solid. Okay, and we see that right here. So as the reaction proceeds, what is going to happen to this electrode right here? It's actually going to be getting smaller. So this electrode right down here is going to go from something that looks like this, and after the cell starts to run for a little bit, it's going to look like kind of getting thinner and thinner and losing mass at this electrode. Now this electrode is gaining electrons, and Pb that is in solution is turning into Pb solid, so this one is going from something like this, and what it's doing is that it's turning into and getting bigger. It's gaining mass. Okay, while this one's losing mass. Okay, and we're going to also talk about this weird little thing right here. But the whole point of this is, since this is losing electrons and the electrons are going through this wire, we are producing electricity with chemicals. And that's why it is a electrochemical cell. Okay, and we're going to talk about how much, later on we'll talk about how much electricity we're producing, and how to calculate how much electricity or volts that we're producing. Okay, so but let's move on and talk more about how this cell works. But since this solution right here is becoming quite positive because of all the Zn coming in here, the Zn becomes quite positive, and Pb2+ is turning into Pb solid, and it's leaving behind in this solution NO3-. Okay, so it's leaving in this solution NO3-. This solution is becoming quite negative. Now, what happens is this positive Zn2+ is attracted to this negative solution, and it moves, well, maybe I'll do it in red. It moves into this tube right here, and it starts to move towards this negative solution. The NO3, so NO3- that's in this solution, is negative, and it's attracted to and wants to move towards this positive solution. So there's, on top of the flow of electrons that are moving through the wire, there's a flow of ions that are moving through this tube. This tube is called the salt bridge. So salt, we know, is just ions, and it just bridges these two pieces so that Zn2+ can move towards this negative, and it kind of allows for the reaction to continue. If you remove this salt bridge, this reaction is going to become, or this solution right here is going to become too positive, this solution is going to become too negative, and the reaction is not going to proceed at all, and you'll have 0 volts. But since we allow these positive ions and these negative ions to move up and through this salt bridge, it allows our reaction to proceed, and therefore we can have ions continually being, or sorry, electrons going through this wire, and therefore we can have electricity. So let's get a few more definitions going. So again, we have a flow of electrons. Electrons always move from anode to cathode, as we talked about before. This is our anode. and here is our cathode. And electrons are moving in this way. Okay, they're moving from anode to cathode. Okay, through this wire. Now, what happens is this is what electricity is. Okay, and this is what our flow of electrons looks like. So often a question will say, draw in the electrochemical cell the flow of electrons, and you would draw something like this, these little arrows, or you draw something electrons going in this direction like this. Okay, electrons. And the flow of ions, again, we talked about that. You have Zn2 plus moving into here, and we have NO3 minus, so that's right here, is also moving into this bridge because they're attracted to each other. This prevents a buildup of ions and allows the reaction to proceed. And so again, positive ions like Zn2 plus move towards this cathode side, and the negative ions move towards the anode side. Okay. Now, this is how we can allow a reaction to, again, this is how a reaction proceeds, is having this exchange of ions. Okay, the electrons moving through here is how we get the electricity.